Assalamu alaikum. How are you, students? Hope all are fine by the grace of Almighty Allah. So welcome back to my physics class. Today I am here to take class for standard 9. Dear students, in chapter 6 I have explained many topics and few topics are left. So the topics which are explained, among those topics I will show you some mathematical problem today, and I will also give you one math as your homework. You will submit it in the messenger page by tomorrow. So let's start the class. A number problem. Area of a copper plate and a steel plate at 10 degrees Celsius is 9 square meter each. After applying heat, temperature becomes 50 degrees Celsius, and due to this, the area of steel body becomes 9.01202 square meter. Coefficient of superficial expansion of copper is 22 into 10 to the power minus 6 per Kelvin. This is your STEM for 1 number creative question. A number, determine the coefficient of volume expansion of copper. Superficial expansion is given and we have to find out volume expansion. B number, by increasing the temperature, is it possible to place the copper plate on the steel plate equally? Express your opinion mathematically. So let's do the solution of the math. Here coefficient of superficial expansion, that is beta, is given 22 into 10 to the power minus 6 per Kelvin. Superficial expansion means expansion in area. And you have to find out gamma equal to what? That is volume expansion. So for finding out gamma, you have to find out at first alpha, because you know beta equal to twice alpha and gamma equal to thrice alpha. Okay, so alpha at first you have to find out alpha equal to beta by 2. So dividing beta by 2, dividing the value of beta by 2, we can easily find out the value of alpha, and it comes 11 into 10 to the power minus 6 per Kelvin. Okay, so gamma equal to 3 alpha. Now you put the value of alpha in the equation and you can get the value of gamma equal to 3.3 into 10 to the power minus 5 per Kelvin. Do you understood the math? In B number question, B number question was what? You have to place copper plate on the steel plate equally. So initial area of the copper plate A1 equal to 9 square meter, and initial temperature of the copper plate theta 1 equal to 10 degrees Celsius, that is in Kelvin scale 283 Kelvin. If the copper plate has to be placed on the steel plate, then its final area must be equal to the steel plate, area of the steel plate, which was 9.01202 square meter. So here the A2 final area of the copper plate, that is A2, also will be equal to 9.012024 square meter. So coefficient of superficial expansion of copper is 22 into 10 to the power minus 6 per Kelvin. Look, here all the informations that are given in the question, that is related to coefficient of superficial expansion. So beta equal to A2 minus A1 divided by A1 into theta 1 minus theta 2. And here we have to find out the final temperature theta 2, because in order to place copper plate on the steel plate, its final temperature should be increased. So what will be the final temperature, increased final temperature? We have to find out that. That means we have to find out theta 2. So theta 2 equal to, it comes like this by calculating all this if we put the values of A2, A1, beta, theta 1 in the equation, then we can get the value of theta 2, that is equal to 343.73 Kelvin, and in Celsius scale it is 70.73 degrees Celsius. So if you increase the temperature of the copper plate is 70.73 degrees Celsius, then it is possible. That means it is possible to place the copper plate on the steel plate equally. Have you understood? Now 2 number. In the 2 number stem is a figure. So in the above figure, the length and breadth of the rectangular metal piece are respectively 4000 millimeter and 3000 millimeter. The surface area of the figure is increased by 0.1 meter square for the rise of temperature 30 degrees Celsius. A number, find the coefficient of linear expansion of the metal piece. Linear expansion. And in B number, what will be the increase in temperature to increase the surface area of that metal by 5%? Analyze mathematically. So let's do A number at first. Answer. Length of the metallic piece is L equal to 400 millimeter. That is equal to 4 meter, isn't it? And breadth or width equal to 3000 millimeter, that means 3 meter. Temperature increase del theta equal to 30 degrees Celsius, that is equal to 30 Kelvin. You have to remember one thing, that temperature difference of 1 degree Celsius equal to 1 Kelvin. Area increase del theta equal to 0.1 meter square. Look here, it is given. So for B number again, for A number, find out the coefficient of linear expansion of the metal piece. But here we are seeing the information, those are given, that is related to superficial expansion. Okay, so from beta we have to find out the value of alpha. So at first we have to find out the value of beta. Initial area A1 equal to length into breadth, that is equal to 12 meter square. For finding out the value of coefficient of area expansion, we need initial area. Beta equal to del A divided by A1 into del theta. Here del A equal to 0.1. Previously I have shown you, it is given in the question. And A1, it comes 12 meter square into 30. So beta becomes 2.77 into 10 to the power minus 4 per Kelvin. Okay. From it, we can easily find out the value of alpha, that is coefficient of linear expansion. So if the coefficient of linear expansion is alpha, then beta equal to twice alpha. So alpha equal to beta by 2. Then dividing beta, the value of beta, by 2, we can easily get the value of alpha, that becomes 1.39 into 10 to the power minus 4 per Kelvin. And it is the answer of A number question. So let's do B number. B number question was what? Again look at B number question. What will be the increase in temperature to increase the surface area of that metal by 5%? That means the increase in surface area by 5%. This 5% will be on the initial area. Okay. So what will be the increase in temperature? That means del theta, we have to find out the value of del theta, increase in temperature. So from A, initial area of the metallic piece A1 equal to 12 square meter. Coefficient of area expansion beta equal to 2.77 into 10 to the power minus 4 per Kelvin. According to the question, area increase equal to what? Del A equal to 5% of A1. That is, in this way, we can get the value 5% means 5 by 100, 0.6 meter square. If the temperature increase is del theta, then beta equal to del A by A1 into del theta. From here, we can easily find out the value of del theta because we have beta, we have del A, we have A1, but we don't have del theta. So del theta becomes, by putting all the values, 180.5 degrees Celsius. Therefore, temperature is needed to be increased by 180.5 degrees Celsius to increase the area of the metallic plate piece by 5%. Have you understood the math? If you still have any problem, you can message to me. Dear student, now it's the time for homework. So there is a homework for you. You must do it, and you will submit it by tomorrow. By within 8 p.m. You will submit it. So goodbye.